Hello and welcome to this video. So, we will talk about the basics of logic, or we will start off with the basics of logic with this video, and in particular we are going to talk about propositions, truth tables and connectives. So, let us get started. So, a proposition is a declarative sentence, and by that I mean one that declares a fact which is either true or false but not both, alright. And furthermore, the truth value of a proposition is true, denoted by capital T if it is a true proposition, and the truth value of a proposition is false, denoted by capital F if it is a false proposition. So, let us look at some examples of this. So, here is the first example. This is a sentence which says India is a part of Asia, right. So, first of all, this is a statement that is either true or false. In particular, it happens to be true because India is a part of Asia. The second sentence is the sun rises from the west. Again, this is either true or false, and from everyday experience we know that it is actually false. So, this is an example of a false proposition. Here is one more, 1 plus 1 equal to 2. Again, this is either true or false, and we know that it is true. So, it is a true proposition. And finally, 2 plus 3 equal to 4, right. Again, a statement that is either true or false, a declarative statement that is either true or false, and it happens to be false. Right. So, this is an example of a false proposition. Let us also look at some non-examples of proposition, namely sentences that are not propositions. Right. So, here is one, come here. Come here is either a request or an instruction. It is not a declarative sentence that is true or false. Right. Have you had lunch? Right. Again, this is a question. It's not a declarative sentence that is either true or false. So, have you had lunch is also not a proposition. X plus 3 equal to 5. Alright, so now this is a little more trickier. Now, whether this is true or false depends on the value of x. Right. So, strictly speaking, it is not a proposition, but as you can already see, it's actually fairly close to being a proposition. But as of now, this is not a proposition. Alright. Now, just as with algebra that you might have seen in middle and high school, with logic you also have variables, right. And with algebra you typically denoted variables by letters such as x, y, z and so on. Here for propositional variables we use letters such as p, q, r, s or p1, p2, p3 to denote these propositional variables. And just as with algebra, wherein we use these variables to construct things like polynomials, which are other functions, with propositional variables as well, we will use them to build new propositions which are called compound propositions, and these are formed from existing propositions using logical operators or connectives, which we will see in the next few slides. So just as with algebra, wherein you had variables and you used addition and multiplication to form polynomials, similarly, analogously with logic, you use these propositional variables in order to form new propositions called compound propositions. So, let's look at the first example of a logical operator or connective, and this is called negation. Right. So, the negation of a proposition P, which is denoted by negation of P, this symbol that you see, is the statement it is not the case that P is true. And this proposition itself is read as not P or negation of P, and the truth value of the negation of P is the opposite of the truth value of P. Now, in logic we use the notion of a truth table, which we will introduce with this logical operator or connective. So, in a truth table you list out all possible values of the propositional variables that form your compound proposition, and for each of these combinations of values you also write down the truth value of the compound proposition itself. Right. In this case it is a fairly simple compound proposition which is simply negation of P, and this compound proposition negation of P has exactly one propositional variable which is P, right, and this one propositional variable P can take two values which are false or true, all right. And from the definition we can then write out the value of the compound proposition, which happens to be negation of P. If the value of P were false, negation of P is true, which is the first row of your truth table. And if the value of the propositional variable P is true, then the compound proposition negation of P is false. Right. So this is sort of the simplest example of a truth table. Right. So let's now look at another connective or logical operator, which is called conjunction. Let P and Q be propositions. The conjunction of P and Q, which is denoted by P and Q, is the proposition P and Q, what we sort of colloquially think of. And in particular, the conjunction P and Q is true when both P and Q are true and is false otherwise. Right. So let's now go ahead and construct the truth table for the conjunction. Right. So here the conjunction of two propositional variables P and Q is a compound proposition, and it's a compound proposition that involves two propositional variables P and Q, right. And so therefore these two propositional variables can have four possible combinations of values, which are indicated in the 4 rows of the truth table. Right. So either both P and Q are false, that's the first possibility, or the second possibility is that P is false and Q is true. The third possibility is that P is true and Q is false. All right, and the fourth possibility is that both P and Q are true. Right. And if you go back to the definition of what a conjunction is, the conjunction of P and Q is true when both P and Q are true and is false otherwise. So in the truth table, the last row, which is the case when both P and Q are true, you write out the value of P and Q to be true, and for the rest of the rows you write out the value of P and Q to be false. Right. So this is how you construct the truth table of P and Q, which is a compound proposition. Now there is another connective called disjunction, and which we define now. So let P and Q be propositions. The disjunction of P and Q, denoted by P or Q, is the proposition P or Q, what we colloquially think of. In particular, the disjunction P or Q is false when both P and Q are false and is true otherwise. Right. So let's go ahead and construct the truth table for the disjunction. So here again you have a compound proposition which is P or Q, and notice that it is a compound proposition made up of two propositional variables P comma Q. Right. And therefore, as with the conjunction, you have four possible combinations of values that P and Q can take, which are indicated as 4 rows of the truth table. And again, if you go back to the definition of disjunction, you find that when both P and Q are false, P or Q is false. So this you note in the first row of your truth table. When P as well as Q are false, you write that P or Q takes a truth value which is false. Right. And for the rest of the rows, the other 3 rows, you write the truth value of P or Q to be true. All right. So with that we conclude this video, right, and I hope you've understood the notion of what is a proposition, what are propositional variables, what are logical operators or connectives, and what a truth table is and how to build a truth table.